Let's move on. Rectangular, this is a typical problem trying to model an actual situation. Alright? Length 8, breadth 6. That's also lah. Huh? Oh, record already, thank you. Yeah. You never pay attention, I already pressed. But thanks. Good effort. Must be encouraging, okay? Teachers must be encouraging. 8, 6. Find in terms of x the volume of the box. Okay? Volume of the box. Now, can you imagine how the box looks like? Yes? You all can now. You can fold this up, kind of box up, open box up. Okay, no cover one, okay? No cover. So what's the volume of the box? Okay? Does it make sense? The height of the box is x. Correct? Because you are going to fold this part up. Correct? You're going to fold this part up. You're going to fold this part up, fold this part up. So the height is actually x. Correct? Okay, imagine, right? What is the, length? Length is 8 minus 2x. The breadth is 6 minus 2x. Yes? Now it's supposed to find the value of x for which the volume is maximum and state the maximum volume. Now, this expression, no matter how complicated it is, I just want to say that the question did not ask for exact form. The question did not ask you to use differentiation. So actually you don't have to use differentiation. You just have to sketch the graph. Follow? You can use the GC to now sketch the graph. Alright, I'm not going to go through. You can redo it on your own. Sketch that expression and you get a curve. And then you just have to replicate the curve in your solution. Do you have the curve drawn out for you or no? Don't have no curve. Okay. Draw again. Can I emphasize? If this is what you're going to produce in your mid-year exam, just like that, and then just answer like that, not good enough. In your graph, you must label it. What do you need to label? You at least must label your maximum point. Okay, it's from GC, yes. The values are from GC because you take a look. Look here. You actually have the value here. So definitely you need to label this point. 1.13, 24.3. This is the coordinate of the maximum point, and also this is your vertical axis, this is your horizontal axis. Don't just x and y can, because you are also going to label this graph. This is v equals to x. 8 minus 2x, 6 minus 2x. Please label this graph. Please label the maximum point. Then you can safely say from the GC, volume is maximum when x is 1.13, when x is 1.13 and maximum volume is 24. All good. Okay? Example 11. I would like to contrast the phrasing of example 11 with example 10. Can you spot the difference in phrasing? Yes or no? Look carefully. Can spot? Yes? The key word here is use an algebraic method. Algebraic method means what? That means you've got to use algebra and differentiation is counted. Okay? Please wake your friends up if they are sleeping, okay? It's your responsibility, okay? You sit beside him or her, it's your responsibility, okay? Okay? No lah, he's not sleeping, he's fine. Right? Use the algebraic method. Okay? So you got to use differentiation. You cannot use GC anymore, okay? Alright? So, this is the volume. This is the shape. You got a hemispherical cap. You got a cylinder here. You want to find minimum area of metal required if the container is to hold a volume of 110. Okay, let's try and model this. It's all about modeling. Get our attention, please. Now, I'm quite kind. This is not part of the solution. I draw this for you. But in the exam, you have to draw this out. Okay, need not draw very nicely, but you have to define the R and the H. Follow what I'm saying? Yes, you have to define R and H. And you tell me, A is the area of metal. It's made up of a few things. It is made up of first, the bottom circle. Second, the curved surface area of the cylinder. And third, the hemisphere top. There are three parts to it. Does it make sense? Yes? There are three parts to it. The bottom circle, the top hemisphere, and the curved surface. Correct? Let's start from the top then. The top is a hemisphere. The curved surface of a hemisphere is, the curved surface area of a sphere is 4 pi r squared. So half of it is 2 pi r squared. Does it make sense? Then, this part, the curved part of the cylinder. I'm not sure whether you remember. Actually, nothing to remember. You open it up, it becomes a rectangle, right? So what is the length of the rectangle? It is the circumference of the circle. Correct? Which is 2 pi r and times h. This is the curved surface of the cylinder. And of course, plus another pi r squared. This is the bottom. All good. I have a 2 pi r square, I have a pi r square, I combine. Therefore, A is 2 pi RH plus 3 pi r square. I call it equation 1. Come attention, please. Question. Think, everybody think, okay? Use your brain, think, okay? Can we differentiate this now? Think. Can we differentiate this now? Because we want to find minimum, right? We want to find minimum A, right? Question says minimum A, right? You want to find minimum A. Now, you change your arch, you will have a different shape. R is 10 if a different shape, R is 20 if a different shape, R is 20, etc. You are restricted by something. Then you say, hey, why got minimum A? You just, R is 0, then no area. But cannot, right? Because got a restriction, the volume must be 100. You must contain 1. Just like a Coke can, I don't know whether you know. Okay, now the Coke can not very efficient. Now all slim one, right? I don't know whether you remember. What you all do over there? What's so interesting? What? What's so interesting there? So fun, not good looking now, busy. Cannot record. Okay? Coke can. Okay? You want to contain 310 ml. It was calculated such that the radius and the height, you use actually the minimum material. But I don't think it's the perfect shape now. Now it's all slender, right? All your Coke, plus all slender. I don't think it's the most efficient. I don't know, this for styling purposes, but I purely talk about cost. I think the original shape was the most efficient. And some ratio, I don't know what's the ratio, I can calculate. Is what I'm saying? So now you die need to contain 100 cm3. What is you want to find out what is the minimum area of metal required? My question was this, do you differentiate A now? If you differentiate with respect to what? with respect to R. Yes? With respect to R. Is R a variable? Yes, it's a variable. Then differentiate lah. I don't know whether you recall. You must look through the expression. Is pi a variable or constant? Constant. R, is it a variable? Yes, it's a variable. You change R, you change a different shape. Obviously. What about H? It's also a variable. So, my point is this. Oops, sorry. Eh? Supposed to have something here. There are actually two variables, R and H. Am I right? Yes? There are actually two variables. There's R and H. We need to get rid of one, so-called. You need to express A in terms of only one variable. Then how? How? You need to express one variable. I meant you need to express A in terms of only one variable. How to do it? The clue lies here. We have not totally made use of this 100 at all. At all, we have not. And how are we going to do it? Volume oops, what happened? Okay, never mind. I know what to do. You see, it's back. Crazy one, all these things. Goodness. This is the volume of the cylinder. And the volume of the hemisphere is 2/3 pi r cubed. Correct? 2/3 pi r cubed. This is volume of the hemisphere. And you know this very well. Alright? Let us simplify a little. I factorize the pi r square. Pi r square. I get h plus 2/3 pi r. I call this equation 2. Right? Now you know, can I have attention please? I know it's a bit tough going, but can you please focus? Sorry, why? Oh yeah. Sorry. Thank you. You're not sleeping, very good. Excellent. No pi, sorry. This is 100 because given, I think it's printed for you, right? Given that volume equals to 100, right? So if volume equals to 100, then this must be equals to 100. Now you have one equation. You got R and H. You can express H in terms of R. You substitute this guy into area. You will therefore get A purely in terms of R. Follow? You get 2 pi R. H, whenever you see H, you substitute this guy in. You get 100. 4 pi R square minus 2/3 R plus 3 pi R square. Now this may look complicated, but it's just an expression of A in terms of one variable only. Follow? A in terms of one variable only. Then we can differentiate. Then we can happily say, oh, as R changes, A changes, I can do the ADR. Got it? So, never mind, let's try and simplify this first. Then you get A. Alright? You multiply this in, blah, blah, blah. You get 200 over R. Yes? Yep, 200 over R. You multiply it in, you will combine with this guy. In the end, you get a plus 5 pi r square over 3. I don't care how I get there, it's just combining, okay? Okay, now, from this point, can I have attention, please? From this point, there's not much copying, but I hope you follow. This is technique of differentiation, okay? Chapter 8, you just differentiate accordingly. For minimum A, the ADR is 0. One equation, one unknown, you get an R equals to cube root 60 over pi. Done. Finish. I want to emphasize this. All look up. All of us may stop here if you were doing an exam. You are very happy that you get a particular R value, You are, then you say, yay. But you have only shown, can I have attention please? Rengi, you're not doing your job. You have only shown that at R equals to, hey, spoil. Hey, wow, so bright. At R equals to this, it is a stationary point. You have not shown that A is minimum, A may be maximum. So you definitely need to do a first or second derivative test. So that's how you do it. This is super important. Alright? Then you say, okay. Now, actually, how do you do your first derivative test? Anyhow, only, right? What? First derivative test? Huh? First derivative test, okay? How do you do it? You got this value here, you're going to substitute. If you substitute into this, thank you, you know that you will get 0. Follow? What you will do is you can either really substitute values, that means use your calculator, what is this, then you substitute values, or you can use a little bit of, how do I put it? Common sense. Now, if you know you substitute this value, you already get a 0. Now, substitute a little bigger, a value a little bit bigger. I'm going to go through, you all focus, need to follow me, otherwise you can't. If you get an R that is slightly bigger than this, does it make sense that this value will be slightly bigger? Right? That means more will be bigger. If you substitute R that is slightly bigger than this, that means the denominator will be bigger. Whose laser point? The denominator will be slightly bigger. The absolute value will be slightly smaller. So you minus something that is slightly smaller, the overall number will be bigger. So therefore you get positive. Follow what I'm saying? Roughly lah. If you're not confident, never mind, just key into a calculator, can? The same way, you will get this negative. Technically, actually, you don't really have to substitute as exact numbers. But if you are not sure, please do it. But you definitely have to show, and after that, you get a value, minimum area is 112.2. You substitute it. Is that right? Oh, finish! Clap!